Yo, what's up, crew? Here we are. Thursday's lesson today. We are dividing mixed numbers today. If you've been keeping up with me all week with division, then this is not going to be a big deal for you. Those of you that have been working hard get rewarded, right? Because you're going to understand this stuff a little bit better. So I'm super excited for you. Mixed numbers, just like with multiplying, have to be turned into improper fractions before you can divide them. But then beyond that, it's just the same thing that we've been doing the rest of the week. So let me go ahead and give you a few examples here. The first one here, we'll do 3 and 3.5 divided by half. Okay, now in order to divide fractions, we should know by now, you multiply by the reciprocal, right? You flip the second fraction and then just multiply it. That's how we would divide. But with mixed numbers, just like with multiplying normally, you have to turn them into improper fractions first before we can continue out with the multiplication. That process, if you remember, looks something a little like this. Whenever you see a mixed number and you've got to do some kind of operation with it, like dividing or multiplying, take the denominator times the whole number. 2 times 3 is 6. Add the numerator, which is 7 total halves that we're talking about, right? 3.5 is the same as having 7 halves. For example, if we're talking about candy bars, 3.5 candy bars would be the same as having 7 half candy bars. Okay, but the difference is we can use this to help us solve this problem now because it's useful to us. So we have 7.5 or 7 halves divided by a half now. Now that we've got two fractions, now we can continue with our division. Multiply by the reciprocal, right? If I want to divide 7 halves by a half, all I have to do is turn this into a multiplication problem and flip my second fraction, right? Find that reciprocal. And now once I do this right here, it should give me an answer, which I can then simplify to get my final answer. 7 times 2 is 14, and 2 times 1 is 2. And I end up with 14 over 2. Now, like always with our fraction problems, how can you simplify it, right? Do I divide both the numerator and the denominator down to make it a simpler fraction? Or if it's an improper fraction like this one, do I just divide, right? The numerator by the denominator. And in this case, since it's an improper fraction, just divide the numerator by the denominator, 14 divided by 2. If you have 14 halves of something, then you really have 7 wholes of something. The answer to this problem is 7. There's on your screen to see all the work for that problem there. Let's do 2 more. We're going to do these ones together. I'm going to put them up on the paper here. You're going to solve them on your own. Pause it, do it, and then unpause it, see if your work matches up with mine. Excellent way to learn, as always. Let's do 2 2/3 divided by 1 1/6. 2 2/3 divided by 1 1/6. What I would like you to do is, in order to divide these, turn them into fractions first by turning these into improper fractions, then carry out the division. Pause now. Hopefully you're back and you got an answer for me, and you can compare and see how you did. I'm going to multiply and then add here. 3 times 2 is 6, 7, 8 thirds. Okay, so 2 2/3 and 8 thirds are equivalent. Divided by 1 1/6. So if I multiply here and add here, that's 6 times 1 is 6, plus 1 is 7. So that's 7/6. Now that they're both fractions, I can divide them. And in order to divide fractions, I actually just multiply by the reciprocal. So I flip this. 8 times 6, 48. 3 times 7, 21. It's an improper fraction, so I know I got to divide this down. So off to the side here, I'm just going to do, we'll go over here. 48 divided by 21. 21 goes into 48 2 times, which is 42. And 6 left over, so it's 2 and 6 over 21. So this is equivalent to 2 and 6 over 21, which would be a fine answer. This is actually a really good answer. And if you got this far and you got something close to this, then that's really impressive, actually, to make it this far and get that. There is one more small step that we're going to do to this, and that is simplify it one more time, because Not only did we turn it from an improper fraction to a mixed number, but this fraction 6 over 21 can be simplified down to make this an even better answer. 6 and 21 share a common factor of 3. So instead of 2 and 6 over 21, we can have it as 2 and 2 over 7. 2 and 2 sevenths. But then again, this is a really impressive answer if you were able to get that far. So I can show most of my work here. Turn them into improper fractions. Got here. Flipped and multiplied here. Multiplied by the reciprocal. Got this. Turn that back into a mixed number, and then simplify that mixed number. Let's do one more. Let's go 4 and 1, 6. Divided by 10. 4 and 1, 6 divided by 10. Pause it. Try this one out. See if you can get it. And hopefully you tried something. If you didn't try anything, then you're probably not going to learn anything. But if you did try something, and you're about to compare yours to mine, then you're probably going to find something out about yourself. Here it is. This needs to be turned into an improper fraction. So I'll multiply here and add here. 6 times 4 is 24, plus 1 is 25. 4 and 1, 6 is the same as having 25 sixths. And we're going to divide that by 10. But in order to help us out here, we're going to turn 10 into a fraction just by putting 1 underneath it. So now that I've got them both fractions, I've got everything kind of set up and ready for me to go. Now I can divide. And in order to divide fractions, multiply by the reciprocal. So I'm going to take 25 sixths, leave it the same. And I'm just going to multiply by the reciprocal of 10, which is 1/10. This got flipped. Notice how the first fraction always stays the same. And then I'll multiply through. 25 times 1 is 25. And 6 times 10 is 60. So this actually turns out to be a proper fraction, right? Where the top number is smaller. So all that needs to be done here is it needs to be reduced down. So I start thinking to myself, well, what are some things that multiply to get 25? 1 times 25. And I try to think to myself, could either of those be used to divide 60 down? No, neither of those can. But also 5 times 5 gives you 25. Can 5 be used to divide 25 down? Obviously. Can 5 be used to divide 60 down? Yes, it can. 5 is a factor of both of them, so I'm going to divide them both by 5. 25 divided by 5 is 5. 60 divided by 5, 12. The answer to this one? 5 12. Hopefully you did well on this, and if not, it's cool. It just means you need a little bit more practice, which we've got plenty of time to do. Ask me if you need any help. I'm here for you. Got a couple problems in your assignment today. Practice those up, and we'll get ready to move on to some word problems tomorrow.